Good afternoon, everyone. My name is Jeff Whitson, and I'm currently enrolled in Savvy Coders Data Analytics and Python Bootcamp. A little bit about my background. I served 12 years in the Marine Corps Reserves, starting in 2005 and getting out in 2017. During that time, I was able to go to school, and I received a bachelor's and a master's degree in petroleum geology. I also completed a MBA. Um, I'm a licensed professional geologist here in California, and so geology really interests me, and especially the goals of the California Geologic Energy Management Division, which is what I did my capstone project on. I wanted to analyze and basically look at the production of oil, gas, and water from 2020 through 2023 and determine if the same operators are the top producers and if there's any change in that and if what effect that could have for the future. So I'm going to go ahead and share my screen and we can go ahead and look into this. Okay, so once again, we're going to be looking at the California oil, gas, water, and injection history from 2020 through 2023. The question that I have is which operators produced the most oil, gas, and water in California from the year 2020 through 2023? My hypothesis is that I believe that the larger corporations will have produced the largest production volume in contrast to the smaller companies. And the approach I took was to utilize the California Geologic Energy Management Division's public reporting data to determine the operator's production volumes over the last 4 years. The data collection and transformation was done in Python, and the analysis was done with SQLite and Tableau. So let's go ahead and look at my Python. So throughout the Savvy Coders course, we learned skills in Python about how to create libraries, how to utilize libraries, how to use lists, dictionaries, data frames, and then how to manipulate data within it. So I first needed to, like I mentioned, identify the information from the Wellstar public website. So I went ahead and found out which information I need. I then imported the different libraries that I would be using throughout my script. I defined the years we plan to download from CalGEM, which was the 2020, 2021, and 2022 and 2023 production, injection, and then the well files. After defining that, I wrote a for loop to iterate over each year that we plan to download. After that, I created a dictionary of file names for each data set we plan to work with. As you can see, I use CalGEM file names equals the dictionary, and then I have well files and then format, and then the year will be inserted into the California oil and gas wells.csv. After that, I constructed the CalGEM URLs needed to download the data sets. After that, I've hit a roadblock because the CalGEM website wasn't allowing me to pull the information in through Python. So I was able to, use Google, find this Stack Overflow that explained a way to work around that issue. And so I created a dictionary with headers as the variable name. And then I placed that in the options so it would override that. So I create my 3 data frames for each of the data sets, and then I format the data as CSV using the pandas read CSV. And then I add column years to the data frames in each year downloaded. I didn't want the report year that it gave me because the report year had time in it too, like, hours, seconds, hours, minutes, seconds. I just wanted to isolate the year. Then I write the downloaded CalGEM data to the CSV file. And then I create a connection with SQLite database using the disk engine. And then I write the data from each data set into the corresponding database table. And then I use this time library to essentially tell CalGEM's web or tell Python to wait 5 seconds between pulling the information from the CalGEM website. So after that, I went ahead and flattened each file. So here I do the same thing. I import and then I specify the CSV file path. And then I create another library with lists within it. And then I go ahead and write for loops to flatten the well file, the production file, and the injection file for each year into 3 separate large tables. From there, I went ahead and used SQL. So let's go back to my presentation. I used SQL to look at, I wanted to look at the operator, the report year, and then the total sum of oil, gas, water, steam, gas injected, and then I wanted a count of the well status. I joined the production and injection table on the wells data table, and then I grouped by the operator and report year, and I wanted to order by the total oil, and I limited it to 20. And as you can see, Chevron has the top oil production for 2023, 2022, and 2021, and 2020 actually. And then below that is Barry that comes in. I then wanted to see the bottom 20 producers, and from this list, it's the exact same thing, just ascending that we just looked at. But the difference is, as you can see, there's no oil, gas, water, or steam that was produced over those years. This is important because CalGEM, California in general, is trying to become carbon neutral by 2045. And so the mission of CalGEM is to start the decommissioning of wells. When it comes to the big operators like Chevron and Era and some of the ones we looked at just a second ago, those will inevitably and most likely abandon their wells to standard and not leave wells behind for California taxpayers to potentially have to, pay to have abandoned properly. So let's move on and look at some of the visualizations. So here we're going to look at the top 10 oil producers. So as you can see, Chevron was the top oil producer over the course of the 4 years that we looked at, followed by Era, then Sentinel Peak, and so on. You can see that if we hover over Chevron, produced about 129 million barrels of oil in 2023 versus Era's 120 million barrels in 2023. And in 2022, Chevron had 129 million barrels and Era had 119 million barrels. So the numbers for these two are actually quite close. But then there's a significant drop when you get into the next operator and so on and so forth. For gas, the top 10 producers changes a little bit. Once it loads, you can see that while Chevron and Era are actually lower than California Resources Elk Hills. This is important because CRC, California Resource Elk Hills, has a major gas field and can produce lots of natural gas. So I wasn't really that shocked about it, but I did kind of expect the Chevron to be a little higher based on the fact that they produce so much oil. Typically, you would have oil and gas in your reservoir, but this shows that the gas has been basically taken out over the years because the reservoir is over 100 years old. So, yep, it's California Resource and then Era and then so on. Now, let's go look at the water production. So the top 10 water producers, this goes back in line with the oil production. You can see Era has a little bit more water than Chevron when it comes to each year. and the water is significantly higher. Every barrel of oil is, well, every barrel brought up to surface from the subsurface is about 97% water and about 3% oil, give or take, with the gas portion. So you can see, like right here, Chevron having a 1.7 billion barrels of water, and then Era having 1.9 billion. What's kind of interesting is how Thumbs has a significant amount of water that they're pulling, and this is down in Long Beach, California. If you look at the oil production of Thumbs, it's not that high. So that just shows a depleted reservoir that they're basically, there's less oil in the pore spaces in the subsurface, and so they're getting less oil than they produce in water, which means that they have to recycle that water or pump it back into the subsurface, and that's where we get into like the injection zones. Okay, and then so here's a graph that shows the oil and gas production over time. Below, down here is gas produced, and then up here is oil or condensate produced. So this is interactive. So like we showed earlier, this California resource, Elk Hills, has this large uh, pinkish color showing that they were the #1 producers of gas. And then up here in the oil, you can see Chevron and Era having the largest, you know, areas of oil. So yeah, if we click on one, it'll show us the gas amount, and then same with if we looked at Chevrons or if we looked at California Resource. Now, after I looked at all of these individually, I wanted to know the well status. The well status is important because with California trying to become carbon neutral by 2045, there's going to be a lot of emphasis on decommissioning wells, which means that they will be plugged and abandoned. So the yellow represents already currently plugged wells. Era leads the way with 125,000 wells plugged over the course of their ownership, and as Chevron has close to 100,000. But here we get into this color, which shows the amount of idle wells. Idle wells are very significant because that means they're not producing oil regularly, and that means there's no maintenance happening on these wells. So with that in mind, these are going to have a better chance of having issues, and with that, a more likely chance that there could be oil migration from like oil reservoirs into freshwater zones. So the emphasis is to have oil companies or operators abandon these idle wells first. And as we move to a more carbon neutral environment, these active wells that you see up here above, like 67,000 and 88,000, will, move into this idle well category, and those will be abandoned. And so with larger corporations or operators like Era and Chevron, the likelihood of them walking away from their wells is low because they have, their business model is huge. They're all around the world. But some of the smaller corporations or operators like Sentinel Peak, which is local to California, might have, less of a reason to, keep their wells. So we really want to focus on some of the smaller operators that, when you look at like Crimson down here on the right, you can see that they only have 5,864 active wells. They have 2,200 idle wells, and they've only plugged about 1,900 wells. And why this is kind of important, and why this will be for future work that I will do, is that if you only have a certain amount of active wells and they're only producing a certain amount of oil per month, and it costs, close to $100,000 to abandon an idle well, how are they going to afford to do that? And that's where we worry that as the state agency, CalGEM, we worry that they would walk away from their wells, file bankruptcy, and then the state taxpayers will end up having to pay for those abandonments. Now here we have just a dashboard of everything I showed you. I wanted to be able to put it onto one dashboard so we could look at it a little differently. So yeah, like I mentioned, we can look at it by clicking on this oil and gas production over time. It's interactive, so it'll change the other graphs and let us know what each year the gas production was. It is on a quarter system, so it will show quarters as the amounts in each of these bar graphs. But this is an interesting part right here, how we can see that there is, 18,000 active wells and 13,000 idle wells for this operator. Also, like I mentioned, we could look at Chevron, and it's going to change, and we'll have 65,000 wells and 23,000 idle wells. I did want to mention this, that Chevron, like you saw, was the top oil producer over the course of the 4-year span, and they have 65,000 wells. And so why I think this is significant is because if you look at Era actually only had, if you remember, about 10 million barrels of oil less than Chevron per year, and they're doing it with only 43,000 wells. So that just shows that Era's business model is just more efficient. Their wells might have new technology, or their reservoir could be in a better place and not as depleted as the Chevron well locations and reservoirs. So the profit margins for Era are higher than Chevron. Okay, so future work would be to analyze the least producing operators to determine the probability of deserting their wells. And after that, we would be able to do a cost analysis of abandoning potential deserted wells and the impact that would have on the California taxpayers. So in conclusion, I just wanted to go ahead and thank Savvy Coders and the staff for all of their guidance and wisdom over the past 12 weeks. I plan on continuing to look into the future work and seeing what I can come up with. And if anyone has any questions, I'll have links in my bio, and you guys can go ahead and send that. So thanks so much for your time. Have a great day.